kitchen. Let's get started. So, happy Monday. Hello. So, focus of today's lecture is talking about your DICE assignment that will be due roughly in 2 weeks. We'll see where we're at by the end of the week and adjust as necessary. So the earliest it's due is October 2nd. Your upcoming assignment, a programming intensive one, is called DICE. So we're making use of object-oriented programming, we're making use of classes, we're making use of nested loops, and math.random from the previous assignment. So you'll find this link under here, Google Classroom. It's just a link to the GitHub page which has all the information that you need. A skeleton of what your program should do, some directions like before on what you should be thinking about, what code you need to write. Then down here, make sure you follow these things in order to get full credit. And if you don't get full credit, I will let you know and send you an email saying, hey, I need to see these things. Please revise so I can give you full credit. So let's take a couple looks at some examples. Randomly, click, 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 click. Ooh, okay. Some of these more advanced. So the goal behind object-oriented programming is like it's easy to recreate things. If you remember from last week, we watched a video by defining objects, it's like making blueprints. So you can see you have dot patterns, a dice class or a die class that's made, and each time you click the screen, you re-roll all the dice that are on the screen. In this case, it's a 4x4, and you sum them all up, right? Whatever is in their totals. Right, so this person, right, all these other dice, it may take a while, but it does re-roll all these things. The sum, I believe, shown in the center of the screen right there, very small. Okay, so whether you make 1, whether you make 16, oh, sorry. Well, Well, okay, one student said they can't hear me. Everyone else, can you hear me? Okay, maybe something on your end. Class, people have confirmed they can hear me. I double-checked, I'm not muted. Okay, well, there's another example. Let's move this down here. Maybe right there. Okay, so you see the similarities here, right? This one, I think yeah, it's randomly chosen, and somehow it scales depending on size too, the width and the height of the dice, so that they all fit. It's nice that in here you see the in-process animations too, even though I press once, it like, the re-roll happens like a bunch of times. Okay. R to auto run, eh? Interesting. And then I can even change the number of rows and columns to make it a ridiculous amount. Very good. So Mr. Simon and I were also talking with this assignment that we should have a competition of sorts on how many, like who can fit the most dice onto the screen, but having it still be like readable. Readable is like determined by Mr. Simon's eyes. And maybe at the end of that, there's like a gift card at the end for something relevant that you all care about. And Mr. Simon and I are like, we'll put in the money to motivate that challenge. So if that's something of interest, like give me a thumbs up, block 1. Who can fit the most dice, readability to the screen, gives you another like 2 weeks to kind of think about, okay, how can I make this better? How can I read it? Yeah, seems interesting, right? And I can just email you the code to whatever gift card that is. Look at that. So as we work through some of the, right here, right? This is like for a challenge, this optional thing right here. So as we're working through these objects, you may want to be getting a head start or starting on your DICE assignment, like what was the resolution? Let's see, good question. We need to specify the parameters. So let me write that down. I have a MacBook Air, so maybe perhaps that's going to be limited. So all good questions. we'll get back to you on that. What else? Okay, yeah. And so last week we worked on the balloon example. You know you gotta write a die class, like one die. So after each lecture, you may want to like start one of these programs, copy and paste it, and gradually fill out what you think goes here. There are parts that we're missing. We haven't gotten to more complicated objects, so as we introduce those ideas bit by bit, I do recommend that you start adding the dice class like start early, start filling in these things so that you're not all overwhelmed 2 weeks later, right? This is definitely not an assignment to procrastinate on, to do the night before it's due. That's the tricky thing with object-oriented programming. When I took a course on it in college, the top students, right, spent like still the like 2 times the recommended amount prescribed by the professor. Object-oriented programming does take time, even for the really like top programmers to wrap their brains around, especially if someone else tells you the requirements, like do this, make it do that, and so on and so forth. Okay. So I've introduced the die assignment, right? Right. So we talked about that. Okay, went over some of the requirements. Not only do they need to be visible on the screen, you're summing up the totals, and yeah, making 1,000 dice should be no problem. Although it might take the computer a while to like render all those dice, so it may time out or glitch. So be careful. I guess like we won't get here just yet. That's more like tomorrow's lecture. So let's review the things we learned from the balloon lecture, right? So that's last week's program, which I have here on the side. And so if you weren't here to join me, towards the end of class, we added these 3 things, these 3 member variables, myR, myG, and myB, to represent its color, right? And to the constructor, which is this whole fancy thing right here, notice the formatting. The name of the constructor is the same as the name of the class. And then over here are a bunch of variables, or formally arguments, that we pass in to determine what makes, or like how do you initialize a balloon. That's the constructor's job. We have these 2 functions inside a balloon. These are the behaviors of the balloon, the member functions. So balloons inflate and balloons show themselves at the screen. This is what makes an object. It's only the like blueprint for an object. It's the template. We haven't made a balloon just yet. We do so down here with Balloon Bob and Balloon Sue. We've declared them in these 2 lines. We've initialized them. Notice the usage of the new keyword. And this is the constructor being called, right? You're telling the computer, hey computer, make me a balloon at X position 225, Y position 150, R color 0, blue color 0, oh no, green color 0, and then blue color 255. These 2 things will take some getting used to. In order to access, or in order to like initializing, all right, calling the constructor isn't going to be enough. So let's say that stuff was commented out. Notice we see nothing to the screen. We just have our 300 by 300 canvas. You have to tell Bob to show himself. Size 0, nothing's appeared on the screen. So then you also have to tell Bob, hey, inflate yourself. So now you see the things being shown. Sue, and we'll do the same thing. Does it matter whether or not you show first or inflate first? Kind of. I think that Sue, the blue circle, is 1 pixel smaller than the red balloon in radius. So I guess if we wanted to have it match up or sync up, you should have the inflate before the show. As a rule of thumb for processing, it is helpful to do any manipulations first, and then the very last thing you do is draw. And that might be a tip for like future programs when you do work on animations. What else should we add to a balloon? Oh, last week, like let's say we wanted to like stop it at a certain point, right? You know that stopping the balloon involves an if statement of some sort. So when you get to a certain size, let's have it like reset, right? Or just stop growing. So where do you think we'll add those lines of code in our program? Will it be inside this draw function? Will it be inside the setup function? Will it be inside the balloon class? Okay, give me a guess. If we want to add code, like an if statement to stop its growing after a certain point, where should that go? Any guesses? Feel free to private message me. Cool, we had some guesses. Nice. People are thinking, they're telling me, okay, yeah. I have majority of people that replied, it should be inside the inflate function, because that belongs to be a balloon. The balloons, after a certain point, like stop, right, and then pop, right? You can't just keep growing on infinitely, so that's a good choice, right? That keeps in line with the behavior of a balloon in the real world. You can put it inside draw, but it's gonna look a little funny, and I can demonstrate that too. And it breaks this idea we'll learn from object-oriented programming. What's it called? I forget the exact word. It's like respecting the variables belonging to each other, right? Or what's it called? There's a vocabulary word for it, and it slips my mind. Like encapsulation or something around private and public variables. So that's why we wouldn't put it in draw, but you could. So let's add it here, right? An if statement. If something, my size, right, is, let's say, greater than 300, what should we do? Let's have it reset its size to be 0. Is that right? Yeah, 300 may vary. So now, let's see. After it gets to 300 pixels, we should see it stop, right? Uh-oh. So maybe we don't want to see the balloons from before. Nice. Another idea, which may be involved in your DICE program, if you want to separate these functions to have your code be a bit more readable, you could also have a new member function. For example, we could have put that into like a pop function. What does it mean to pop? Well, after a certain point, right, this line of code that we had could have gone into here, right? If my size is greater than 300, then you're going to do that. And also, what's it called? I forget if the clear function works in showing what was there before to make it a bit more clean. If we press run, we notice that, oh, after you move the code, hey, Mr. Chan, you didn't call your function. You didn't tell Bob and Sue to pop. So that means the program keeps drawing itself, right? You have to be able, after we added this, you have to be sure to use it down here. Bob.pop. Oh, I think pop is reserved already. Why don't we call it explode instead? You notice how it turned like blue in my editor? Pop might be a word, a keyword that was already reserved inside the processing library. Okay, so that's the change down here. Let's see what happens. Whoa. I didn't know the background would be black. So maybe instead of clear background of that grayish color, do we have a background? What's it, 150, 150, 150? Yeah, kind of. So it popped, right? And whatever that means, it's simple animations, but the idea behind it, that's the new stuff, right? So we've added in this explode function. Double check the time. Okay, I guess we can get started on the following program. For you guys, it's on Wednesday. Let's start the skeleton for a new class called a coin. And maybe we'll just focus on the visual part of it. Okay. So here are the requirements, and I highly recommend that in these coming examples where we make objects, that you use, like you're typing alongside with me. So if you haven't already, go to this slide and then copy and paste this code over here, and we'll modify it so that, or we'll start filling things in to make the beginnings of a coin class. This is slide 57. I got a little more time than expected after talking about these things. I do know to get you out early because it is a Monday schedule. But at least we can focus on the visuals on what it means to like draw a coin. Okay, so I'm on slide 57. I copy and pasted the code from there. I have my processing thing opened. I create a new sketch. So I need to close it. Yeah, I made changes. I'm going to save this. Close that. Now I'm here. Shrink it a bit. Move this over. And paste. So now it's a little bit more complicated. Maybe we want to display the heads and display the tails, the H and the T there inside a circle. And now we're introducing when you click the mouse, like that thing is going to flip. A little thing about the naming conventions. You have to be careful how you name these things because like you can't call it coin. That's going to create this really weird error. So when we copy and paste this, one of the first things, let's go ahead and save it. And we're going to call it coin program instead of just plain old coin. It's a naming convention based on how Java works. The underlying file somewhere along the ways is called like coin.java or something. And processing kind of hides that from us. So it's a particularly nasty bug. So have it named coin program. Cool. Inside the coin class, it looks like we're already given some things, right? What it means to be a coin. So there's three things. Heads is either true, head is or false, right? Either heads or tails, true or false. Then you have a my x and my y, probably a center coordinate of some sort. Oh, the mouse pressing is already done for us. Look at that. When you press the mouse, you're going to redraw the screen. Draw function's empty. The setup function has text align, probably to help us put that H or put that T there. No loop, great. So it only draws once. It doesn't repeatedly draw to the screen. Okay, so at the very top of this slide, we see that we've had the requirements, right? What it has, two sides, position. Oh, we talked about this. Huh. Okay, so I guess the slide it's given us, this idea of flipping, so we can add that in, right? If math.random is less than 0.5, then heads equals true. Else heads equals false. So what's going on here? There's that 50% that it's heads, 50% that it's tails. Notice that it's added into a flip class. We might as well could have put this into the show, right? If we only had one function for the entire coin class, that's like no different than programming like we did before, like for Lightning, putting everything inside your draw function. So we do want to, when we can, make member functions, make new little functions that just have one job. This function's job is just to take care of the coin flip, and that's it. If we need other behaviors, we'll consider writing a new function. This part's a little bit more confusing when we go into the show. No stroke, so it doesn't have an outline. Fill, 255, all the lights are on, so it's going to be white colored. We have an ellipse, at a certain position, my x, my y, 50 and 50. We change the color to black, all lights are off. We now check our variables. If heads equals true, all lowercase, then we display heads on our coin using the text function at my x, my y. Else, so heads is false, we need to display false to the screen. Oops. Neat. I think that's it. No, it's not. We have the constructor that's left. So, we'll keep going. Did we fill out the constructor? I'm like thinking. No, we didn't, right? We did not fill out the constructor yet, right? Let's attempt to use this class. Coin bob, knob. Yeah, this is the part that's kind of weird. Like, we didn't initialize it, and I think that might be okay. Oh, look, we have the shortcut. New coin. All right, this is just like initializing and declaring in the same step. We can initialize and declare a variable, an object in the same line. Bob dot show. Do we want to flip first or show first? I think we need to flip first. And let's see. Click. Nope, nothing's wrong with the screen. I messed up something. Flip, show. Yeah, I do think the initialization did not happen, so we do need to fill out this part right here. So when we first make an object, we have to set its my x equal to whatever the user tells you, my y equals whatever the user tells you, and the weird part is like heads, right? I guess we could do it random, but for now, to save time, let's just make it true at the very beginning. Now let's see if we run. We should see something on the screen. We do not. Oh, yeah, we do. Okay, it's a little delayed, so let's try that again. Okay, so there is a delay. I'm just impatient on this Monday morning. So without even clicking on the screen, after you press the play, you see a white circle with the word false inside. That's because it is rolled once, because I called the flip function. So it doesn't matter that I initialize it to being true. right off the bat it flips, so its value is like random. If I were to not flip it, then you would see the evidence of my constructor of it being true always occur. So what do I mean? That means if I comment this line out, I press play, and now it's always going to be true. It's like a 10-second delay for it to actually appear to the screen. Do it again. Heads. Cool. Hope you're convinced. So we got a head start with tomorrow, Wednesday's lecture. We'll start the next one reviewing some of these ideas, maybe thinking about how to make it more complicated. I don't think we'll make many objects just yet, but if you want to look into like making a row of coins, for example, that might be a good challenge. There are some intricacies there that you can like get a head start in figuring out how the heck does that work with objects. It gets a little weird. Other than that, it is 9:30. I have to let you all go now. Have a good Monday, and remember to do your reflections. It's been posted on Google Classroom. Take care, everyone.